When designing a branch circuit for a UPS, it's crucial to understand how overcurrent protection devices like breakers interact with receptacles and the overall circuit load. In your scenario, the UPS has a capacity of 3000 volt amps and 2250 watts at 120 volts, resulting in a calculated current draw of 25 amps. The National Electrical Code, or NEC, requires you to increase this calculated current by 125% for continuous loads. This 125% factor is applied because a continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. This calculation results in a value of 31.25 amps. Based on this, you selected a 35 amp breaker. However, the UPS input connection is an L5-30R receptacle rated for only 30 amps. The problem is the 35 amp breaker does not protect the 30 amp receptacle. The purpose of a circuit breaker is to protect the conductors in the branch circuit from overcurrent conditions such as short circuits or overloads by interrupting the circuit when the current exceeds the breaker's rating. It is designed to protect the wiring from overheating and potentially causing a fire. In this case, the 35 amp breaker will only trip if the current exceeds 35 amps. If the UPS draws more than 30 amps, but less than 35 amps, the L5-30R receptacle could overheat and potentially fail before the breaker trips. The receptacle is the weakest link in the circuit. Here are a few solutions to address this issue. Firstly, you could replace the existing L5-30R receptacle with an L6-30R receptacle. This receptacle is designed for 30 amps at 250 volts instead of 125 volts. However, simply changing the receptacle might not be compliant. The receptacle must match the voltage of the power supply feeding it. Secondly, consider installing a 30 amp breaker in the panel. This will protect the 30 amp receptacle, ensuring that it does not exceed its rated capacity. However, this solution might not be ideal if the UPS truly requires a 31.25 amp overcurrent device after applying the 125% factor. In this case, the breaker might trip unnecessarily during normal UPS operation. Thirdly, using a cord and plug rated for 35 amps is another potential solution. However, ensure that the cord and plug are compatible with both the UPS and the power source. In addition to these options, consider the following important points. Firstly, always consult the UPS manufacturer's specifications for the recommended circuit breaker size and receptacle type. The recommendations should take precedence. Secondly, check the National Electrical Code, or NEC, Article 210.21 bone and Table 210.21 bone for the allowable ampere rating of receptacles. For example, a 30 amp rated receptacle is allowed on a 30 amp branch circuit. However, the overcurrent protection shall not exceed the ampere rating of the receptacle. Thirdly, verify the ampacity of the conductors in the branch circuit. The conductors must be sized to handle the calculated load current, including the 125% factor for continuous loads, and be protected by an overcurrent device that is properly sized for the conductor ampacity. Refer to NEC Table 310.15b16 for conductor ampacities. Fourthly, consider using a 30 amp fuse instead of a breaker. Fuses are generally more accurate in their tripping characteristics and can provide better protection for sensitive equipment. However, fuses require a dedicated fuse holder and might not be as convenient as breakers. Finally, it is highly recommended to consult with a qualified electrician to ensure that the branch circuit design complies with all applicable electrical codes and regulations and that the UPS is properly protected. In summary, the key to properly designing a branch circuit for UPS is to carefully consider the UPS load requirements, the receptacle rating, the conductor ampacity, and the overcurrent protection device. Never exceed the receptacle's ampacity with the breaker size. Consulting the manufacturer's specifications, adhering to the National Electrical Code, or NEC, and seeking guidance from a qualified electrician will help ensure a safe and compliant installation. Remember that electrical work can be dangerous, so it's always best to leave it to the professionals. By understanding these principles and following the NEC guidelines, you can ensure that your UPS is properly protected and operates safely. The 125% factor for continuous loads is a critical consideration in sizing the conductors and overcurrent protection. Ignoring this factor can lead to undersized wiring and potential overheating. When selecting a receptacle, make sure it is rated for the appropriate voltage and amperage for the UPS. Using an incorrectly rated receptacle can create a safety hazard. Overcurrent protection devices, such as breakers and fuses, are designed to protect the conductors in the branch circuit. They are not intended to protect the receptacle itself. The receptacle is the limiting factor in the circuit and must be rated to handle the maximum current that the UPS can draw. It is important to understand the difference between the ampere rating of a receptacle and the interrupting rating of a circuit breaker. The ampere rating of a receptacle is the maximum amount of current that the receptacle can safely handle. The interrupting rating of a circuit breaker is the maximum amount of current that the breaker can safely interrupt during a short circuit or overload condition. In your situation, the 30 amp receptacle is the limiting factor. If the UPS draws more than 30 amps, the receptacle could overheat and potentially fail, even if the 35 amp breaker does not trip. To resolve this issue, you have several options. Firstly, replace the 30 amp receptacle with a receptacle that is rated for a higher amperage. Secondly, install a 30 amp breaker in the panel. Thirdly, use a cord and plug that is rated for a higher amperage. When selecting a cord and plug, make sure they are compatible with both the UPS and the power source. Also, ensure that the cord is sized appropriately for the amount of current it will be carrying. It is important to follow all applicable electrical codes and regulations when designing a branch circuit for UPS. The National Electrical Code, or NEC, provides detailed requirements for the installation of electrical equipment, including UPS systems. Consulting with a qualified electrician is highly recommended to ensure that the branch circuit design complies with all applicable codes and regulations. A qualified electrician can help you determine the correct size of the conductors, the overcurrent protection device, and the receptacle for your UPS system. They can also ensure that the installation is safe and compliant with all applicable codes and regulations. Failing to follow these guidelines can result in a hazardous situation, including electrical shock, fire, and equipment damage. Always prioritize safety when working with electricity, and consult with a qualified electrician if you have any questions or concerns. In addition to the above considerations, it's important to periodically inspect the branch circuit for any signs of damage or wear. Look for loose connections, frayed wiring, and damaged receptacles. If you find any problems, have them repaired immediately by a qualified electrician. Regular maintenance can help prevent electrical hazards and ensure that your UPS system operates safely and reliably. Finally, remember that electricity can be dangerous. Always take precautions to protect yourself from electrical shock when working with electrical equipment. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses, and always disconnect the power before working on any electrical circuit.